Combined series. Knowing how to deal with arithmetic and geometric series allows finding many more things related to combined series, such as for example in series with rational terms, where numerators form a different pattern from denominators. Let's consider an example to clarify this point. Example 1. Calculate the sum of the first 30 terms of the series deriving from the sequence. We have the following shown on screen. Solution 1. It is evident that numerators form an arithmetic sequence where the first term is x1 equals 1, and the common difference is d equals 2. On the other hand, denominators form an alternate sequence with terms 2, 4, 2, 4, etc. Therefore, it is better to form two separate arithmetic sequences, one containing only fractions with denominator 2 and the other only fractions with denominator 4. Therefore, finding the sum of the first 30 terms of this combined sequence means finding the total sum of two separate series with 15 terms each, i.e. we have the following shown on screen. Thus, for the numerators of the first series S, A, we have x1 is equal to 1 and d equals 4. Therefore, the 15th term, n, equals 15, of this series of numerators, we have the following shown on screen. This means the true values of the first and the 15th terms of S, A are, we have the following shown on screen. Moreover, the true difference of this series is d, a, equals 4 over 2 is equal to 2. As for the numerators of the second series S, B, we have x1 is equal to 3 and d equals 4. Therefore, the 15th term, n, equals 15, of this series, we have the following shown on screen. This means the true values of the first and the 15th terms of S, B are, we have the following shown on screen. Moreover, the true difference of this series is d, b equals 4 over 4 is equal to 1. Therefore, the values of the corresponding series are, we have the following shown on screen. We have the following shown on screen. Hence, the sum of the first 30 terms of the original series is shown in the following on screen. Sometimes, the situations involving series are given in the form of the question. Example 2. The sum of the first n terms S, n, of a particular arithmetic progression is given by S, n, equals 2, n plus 5, n squared. Find the first term and the common difference. Solution 2. Since the sum of the first n terms in an arithmetic series is shown in the following on screen, we can write for the specific case the following shown on screen. Doing some equivalent transformations on the right side yields we have the following shown on screen. Therefore, comparing the terms on both sides, we obtain x1 is equal to 4, the first term, and xn equals 10, n, the general term. Hence, since in an arithmetic progression, we have the following shown on screen. Then, the expression for common difference d, we have the following shown on screen. That is all for lesson 12.2.6. To continue this tutorial, please watch 12.2.7, the practical applications of number series and sequences. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.